Jacob is here. I think he went to. Do you have any question on the take-home problems? Have you guys done the take-home problems? You have not yet? Yeah, but the exam was supposed to be on Monday. But the way things are, I don't know whether we can still have exam on Monday. We can have exam. Jacob, have you completed the take-home problems? You have questions? Normally, exam is supposed to be on Monday, and you will use your take-home problems. So I wanted to know if you have any question solving any of them so that we can go over it. Thank you. Would you be ready with the take-home problem on Monday, Mason? Would you be ready with it on Monday? So if you have questions about it, you can send me an email. And so we will have exam on Monday. So we will continue with chapter 5. We started with this example, k over x plus 10 square. Did we finish? Did we find the probability that x is less than or equals to 10? Yeah, we find the cumulative distribution function, and that was. So if x is a continuous random variable and g of x is a real value function, then we can find the expectation of g of x with this formula. We did that already for the discrete distribution, where we were able to find the transformation of a random variable. So this is a more general definition of the mean of the transformation of a random variable. So let's look at this example. Have we done this before? Yeah, from this first example of cx cubed, using this example, we want to find e of x squared. So if you want to find, for example, e of s squared, we will say that let g of x be equal to x squared. So this is a random, this is a real valued function. And we can use it so e of x squared is equal to, I will use the whiteboard at this point because typing takes more time. we will have that E of x squared is integral from negative infinity to infinity of x squared f of x dx, which is 20, integral from negative infinity to infinity, x5, remember that function, this is x cubed times 1 minus x. Minus x dx. So I can write here negative infinity to infinity, x squared times x cubed 1 minus x dx. There is a 20 here. So this is equal to 20 minus x to infinity, x5 minus x6 dx, which is 20 x6 over 6 minus x7 over 7. We have to change this. X was from 0 to infinity. We will be saying in making this type of mistake of 0 to 1, 0 to 1, 0 to 1. Remember that it was defined from 0 to 1. So elsewhere it is 0. So this is 20. It's equal to 20. 1 over 6 minus 1 over 7. 7 minus 6 over 42. 20 over 42. So this is this is E of x squared. We can also just find E of x. E of x is equal to integral from negative infinity to infinity x f of x dx. So for this function, f of x is 0 outside of 0, 1. So we will have integral from 0, 1 x times 20 x cubed times 1 minus x dx. It becomes integral from 0 to 1, 20 x4 minus x5 dx. which is 20, x5 over 5 minus x6 over 6, 0 to 1, which is 20, 1 over 5 minus 1 over 6. 6 minus 5 over 30, which is 20 over 30. Over 3. Now we can look at some other measure of central tendency. Other measure of averages. Starting with the mode, let X, we have defined it before for discrete distribution. We are defining it now for continuous distribution. Let X be a continuous random variable with density function f of x, and the mode of x is the value x at which f attains its absolute maximum. So the value where we have the absolute maximum for a density function, and I want you to observe that the density function can be more than 1, unlike the distribution function. The probability distribution function is between 0 and 1, but f of x, the only requirement is that it is non-negative. So it can be more than 1. Example, find the density, find a mode, if it exists, of the random variable x with density of x equals to 0. F of x equals to 20, x cubed times 1 minus x. If 0 is less than or equal to x, less than or equal to 1, and 0 otherwise. We have a function with this density. And we want to find the modes. So the endpoints here are 0 and 1. And at those endpoints, we have f of 0 equals to f of 1. That's how we are looking for the maximum. We check the endpoints, and then we check the point where the derivative is 0. F of 0 equals to 0. F of x equals to 20x cubed minus 20x. So f prime of x equals to 60x squared minus 80x3, which is equal to 20x squared times 3 minus 4x. Find the derivative of f of x. And the derivative equals to 0 if x equals to 0 or x equals to 3 over 4. You have two ways of determining where it's a local maximum, either by finding the derivative of the second derivative and check the value of the function at the second derivative, or study the sign of f prime of x. If you want to look at the sign of f prime of x, f prime of x will be 0 at 0 and 3 over 4. So it is positive here, and it is negative here. Do you see why I have those signs, positive and negative for the derivative? If you put x equals to 0 here, because this function 20x squared is always positive. So the sign of f prime of x depends only on the sign of 3 minus 4x. So it is also positive here. So we say that in calculus, we learned that the sign does not change, but the derivative becomes 0. We have a point of inflection. So this is a little bit of calculus. Another way to determine if you are achieving a local maximum or a local minimum is by finding the second derivative. Here you can see that you will increase and then decrease. The function will be increasing before 3 over 4 and decrease after. So meaning that it will attain a local maximum at 3/4. Another method is to find the second derivative. Second derivative here will be 120x minus 160, not 160. That's 3 times 8, 24. 240 x squared. So when the second derivative is 0, you have a local, an inflection point. When the second derivative is negative, you have a local maximum. When the second derivative is positive, you have a local minimum. You remember that from calculus? So we are going to check the possible point is 3/4. So what is second derivative of 3/4? (120) times 3/4 minus 240 times 9/16. Here, 120 by 4 is 30 times 3, 90. 90 minus by 4 here, you will have first 60. And 60 by 4 gives you 15. 15 times 9. What is 15? 15 times 9? 15 times 9 is what? 135. Let's write 135. So this will be a negative number. So you have two methods, either the table of variation, the table of sign of the derivative. If it changes from left to right, left is positive, right is negative, then it is an upward curvature. So it's a local maximum. If it is negative positive, it's a local minimum. Or you find the second derivative. When the second derivative is negative, at x equals to 3/4, we have a local maximum. So the mode of this random variable is 3/4. So the mode of this random variable is 3/4. I want us to look at another example. Another example. Find the mode of the random variable x with density function x equals to 1/3 e to the minus x/3. X is greater than or equal to 0 and 0 otherwise. So this is an exponential function as we know. The derivative of f is minus 1 over 9 e to the minus x over 3. This is the derivative. Can this derivative ever be 0? This derivative cannot be 0. But it tells us here that it's a negative function. The derivative is negative. F prime is less than 0. So f is what? Is a decreasing function. F prime is decreasing. So the least value of x is the mode. So x equal to 0 is the mode. Is that right? If you have a decreasing function, then the maximum value of the function is at the beginning because it is decreasing. Now let's look at another measure of central tendency, or another measure of variation. The median. Let x be a continuous random variable with cumulative distribution of x. This probability that x is less than or equal to x. The median of x is the value I'll call it x half, and I will explain later why I use that notation. So that f of x half the ink of my pen is finishing is equal to half. In other words, the median is the point so that the probability to the left of that point is 0.5. Example, let x be a random variable, density function f of x equals to, I want to use this function. Do you remember this second random variable? K over x plus 10. What was K? So for this to be a random variable, K should be 10. To be a density function, I mean. For f to be a density function, K equals to 10. So f of x is equal to 10 over x plus 10 squared. So what was capital F of x? That's what we did last time. When we, after finding K, I think we computed the cumulative distribution. Joseph, can you find it? The cumulative distribution of F. Was mentioned here for this class when we did this cumulative on, I think we did it on Wednesday. But we can still find it if you don't have it on your note. But you should have it somewhere. It's just the integral. It's about finding the integral. So let's work it together. To find the median, we need the cumulative distribution. Integral from 0 to x, 10 over x plus 10 squared, which is 10. Remember, we say minus minus 1 over x plus 10. Do you understand what I'm doing here? To find the integral. It's from 0 to x, so it's going to give us 10 over, I would have put t here. Then we will replace it by 10, it will be minus 1 over x plus 10 plus 1, which is 10 minus 10 over x plus 10. Do you see that somewhere in your note, Jacob? I don't know if Mason wrote it down. Can you check it if you have? So if you have density function and you are asked to find the median, you need to find the cumulative distribution function first. So now that we have the cumulative distribution function, we can solve f of x equals to 1 over 2. That is 10 minus 10 over x plus 10 equals to 1 over 2. That is 10 minus 1 over 2 equals to 10 over x plus 10. So this gives us 19 over 2 equals to 10 over x plus 10. That is 19x plus 190 equals to 20. Look here, we did something wrong here. Jacob, did you really check that it was this? It's 1 minus 10, right? Yeah, we are missing this one. This is 1 over 10. Do you understand why? Because at t equal to 0 here is 1 over 10. So I quickly wrote 10, which was not. Because it wasn't making sense at this point. So this implies x plus 10 is equals to 20, x equals to 10. You know why I knew it was wrong? Because we were getting a negative number and a median cannot be out of the range of the random variable. So do you remember what we found as probability that x is less than or equals to 10? If you can look at it. Median you could just tell us the median at that point. The median is n equals to 10. The median is 10. So I just want us to play with calculus, applying it to probability. Now let's do one more example, then we can go. Example. X is random variable with density f of x. I'm just doing one that we have done already. 1/3 e to the minus x/3. Find the median of x. So if we are given the density as we need to find a cumulative distribution function. So f of x is the integral from 0 to x t dt, which in this case will be 1/3 integral of e to the minus x/3 t, which is 1/3. And here we will have minus what is the integral here? Minus 3 e to the minus t/3 at the antiderivative from 0 to x. Which is equal to minus e to the minus t/3 0 to x, which is 1 minus e to the minus x/3. So to find the median, we will solve f of x equals to half f of x equals to half implies 1 minus e to the minus x/3 is equal to half. That is, half is equal to e to the minus x/3. So this equation is an algebraic equation that you can solve. So applying the logarithm here, we will have logarithm of 1/2 is equal to minus x/3. Logarithm of 1/2 is minus logarithm of 2 x/3. It's equals to 3 logarithm of 2. That's the median for that distribution. So we will learn about mode, mean, and median for a continuous random variable. So as I say, work on your take-home problems. If you have questions, send me an email. And on Monday, we will have an exam which is similar to what you have on your take-home problems.
Oh, I just have a quick question.
Yes.
So would you still want us to turn in our take-home problems today or by Monday?
You will turn it on Monday together with your exam.
Okay.
I want you to use it during the exam. You will use it because the formula are going to be the same. You will not have to remember formula. So you are going to test. Are you going to be in class or you will be on Zoom?
I'm not sure depending on what's going on with the quarantine, but if I was at quarantine,
okay.
I'd come.
Okay. Anyway, you will let me know, but I will connect on Zoom. So,
Okay.
and if you have a question, send me an email.
Okay, thank you.
You're welcome.
Bye.